Hey guys, here's your guys' lecture on conditional probability. I thought I would give you guys some notes before you start getting into your homework assignment. So let's begin. Alright, what you guys are going to go into next is called conditional probability, okay? So, conditional probability, it's the probability that an event will occur given that another event has occurred, okay? And here's the notation that you guys rewrite it in. And the pronunciation is this is the probability of event B given A. So the P stands for probability, you guys. B and A are certain types of events. Now, depending on the problem situation, though there's always going to be, for the most part, two events that you guys will be dealing with. Okay? So, again, probability that an event will occur given that another event has occurred before it. So we are going to be looking to that. One thing I do want to talk to you guys about is this definition right here, which is a sample space. And a sample space, you guys, is simply all the possible outcomes of an experiment. So, for example, if you flip a coin, the sample space, well, what's all the possible outcomes if you flip a coin? Heads or tails. So in the sample space would be heads, tails. If you roll a six-sided die, well, what's the sample space of that? Well, it's all the possible outcomes of that experiment, which is you would get a 1, 2, 3, 4, 5, or 6. So a sample space is just basically what are all the possible outcomes of a certain experiment, okay? So when you guys find this probability, right? Because probability, you guys, it's a percentage, right? Which is a fraction. When you guys actually find that, this is what it looks like. So let me explain. Whenever you guys do conditional probability, this given part, you're going to be using a reduced sample space. Or in other words, you're going to be using the total amount of outcomes that will be in your problem, it's going to be reduced because this is simply how conditional probability is. It restricts the amount of outcomes that will occur. So this is basically to find the probability. So this is finding the actual percentage or fraction. It's the number of occurrences of the desired event in the reduced sample space, all divided by the number of items in the reduced sample space. So again, this is new, so it's fresh, and with that comes uncertainty. But once we do some example problems, then all of this stuff you guys will come together. Okay, so let's look at example 1. All right, so example 1 says a single six-sided dice is rolled one time. Determine the probability that a 2 was rolled given an even number has been rolled. So let's do the sample space first, which is all the possible outcomes. Well, what are all the possible outcomes? Well, 1, 2, 3, 4, 5, 6. So initially, you guys, there are 6 total possible outcomes, right? Now, here comes where conditional probability comes in, right? In this statement, it says given an event, given an even number has been rolled. Okay, so given an even number has been rolled, well, what numbers are those? What numbers are even? Well, in the reduced sample space, it's 2, 4, and 6. So now when we look at this, right, look at the denominator, you guys. It says the number of items in the reduced sample space. So basically, well, we figured out that even number that has been rolled, there's only 3 of them, 2, 4, and 6. So you know this probability is going to be out of 3. Then the top is the number of occurrences of the desired event. Well, what is our desired event? What is our target? It says determine the probability that a 2 was rolled. So within this reduced sample space, what's the probability of rolling a 2? Well, it's just 1, right? Just 1 out of the 3. Let that soak in, process what is happening, right? So let me just recap. There used to be 6 total outcomes. Now, it says determine the probability that 2 is rolled. Okay, so it would still be, if this was a normal problem, and if you disregarded that, it would just be 1 out of 6, right? Okay. But since it says given, an even number has been rolled. So we have to restrict the total amount of outcomes to just even numbers, which is 2, 4, and 6. And then out of this restricted amount of outcomes, which one is a 2? Well, only 1 is. So it's 1 out of the 3. It's a weird way of thinking, but some of you are getting it, and some of you probably not, but that's okay, because it's a process, right? It's a process. Alrighty, let's go to example 2. There's a deck of cards. Alright, I already know the sample space is 52 cards, because that's how many cards are in a deck. Right? So, as you guys are walking me through this, right? With conditional, that's the sample space of the whole entire thing. That's the total amount of outcomes in this experiment, right? 52 cards. I'm going to predict that it's going to shrink because conditional probability, it shrinks the total amount of outcomes that we do have, okay? Let's continue reading. What is the probability of picking a king given that a diamond was picked first? Okay, so all you guys that are really into cards, the probability... Okay, so how many diamonds... So it says a diamond was picked first, right? So that means it automatically restricts our sample space to only diamonds. And there's 13 diamonds in a deck of cards. So, since it says given that a diamond was picked first, it has to be out of 13 now. Because that's how many diamonds are in a deck. Now, what's the probability of picking a king? Well, there's only 1 king in each suit, so there's only 1 king of the diamonds, so it's just 1 out of 13. So, just a recap, right? This probability of B given A, right? So you try to find the probability of your 2 events using conditional probability. When you find your probability, it's the reduced sample space on the bottom, the restricted amount over what you're trying to find, your target. And that's how you guys will find your conditional probability. Alright, so these are the notes for today. I will post a homework assignment and I'll post a homework video of that assignment as well. And it will be due on the assigned date, right? See you guys.